Okay, this is a continuation of our lesson from yesterday. After our introduction on binomial theorem, we're going to go over it a little bit again and start introducing the notation that you used in year 11 for permutations and combinations. Now, the first bit of notation we're going to look at is factorial notation. Does anyone remember what it is? It's the exclamation mark. But what does it mean? For example, 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's an example of factorial notation, but if I wanted to write the general form of factorial notation, for example, n factorial, it'll be n times 1 less than n. How do I write that? N minus 1 times n minus 2 times n minus 3. Now, I really don't need multiplication symbols between those. Times, I'm not sure, times all the way down to 1. So I can just go times 3 times 2 times 1. Look, that's just assuming n is very large. So I go dot, dot, dot. You really don't need to be putting the multiplication symbols between. So you would just go like this. Okay, so that's factorial notation all the way down. Now, combinations. So that's factorial notation. In year 11, we also looked at combinations. And we looked at, but we're not going to look at permutations here, all right? So combinations is with the C. So combinations means that, if you remember from perms and coms, that the order doesn't matter. And it's also called, one of the notations is called choose notation. And you can think of it as, I've got a group of people and I just want to choose some people from that group to help me do something. Now, it wouldn't matter the order in which I chose them if I need 3 people to help me. But, so if I've got 8 people and I choose 3 people to help me, the order in which I chose you doesn't matter. Okay? But if I've got 8 people in a race and I want to know how many ways people can come first, second, third, or all the places in the race, order, of course, matters. Gold medal is different to silver, which is different to bronze. So, whenever you get presented with a permutation and combination problem, you have to think, would it matter the order in which these people stand or the order in which they're chosen? If the order does not matter, and the only time order won't matter is if you're just choosing a group of people, a subset from another set. If you're choosing 3 from 8, or if you're choosing 5 people from 10, the order in which I pick those people doesn't matter. But if I'm choosing those people for positions of president, vice president, yes, order's going to matter. Because president is different to vice president. All right? Georgia? Right. Okay. So, combinations. You know how you've seen an example like 8 choose 3, for example? Example might be 8 choose 3. Can someone work out what 8 choose 3 is on your calculator? So this is a combination. The general form is NCR. Now, how do you work it out? It's 56, but there is actually a formula for it. So 8 choose 3, it's actually 8 factorial over 3 factorial, but it's not just 8 factorial over 3 factorial, it's got something else in the formula. Do you remember? Well, tell me what 3 plus something is 8. All right, now can you on your calculators do the following? You know that 8 choose 3 is 56 because you just worked it out. Can you now do 8 factorial divided by, open bracket, 3 factorial times 5 factorial, close bracket. Tell me what answer you get. So I want you to work that out on your calculator. And you get 56. So therefore, the general formula for n choose r, I've got n and I'm choosing r is what? Have a look at this. Look what we've done. We know 8 choose 3 is 56. 8. So it's n factorial over r factorial times, how do I get the 5? N minus r factorial. So that is the formula for n choose r. So you need to know that formula. So you need to know the formula for n factorial, that it's basically from 1 to 0. Now, let's play around with this as well. Now, there's another way. So actually, this is not choose notation. The one below is choose notation. So you know how yesterday I had stuff like 2 choose 0. I wrote it as a 2 with a 0 underneath in brackets. You can write n choose r as n over r as well. That's another way you can write it. This is actually called choose notation. Okay. There you go. So instead of writing little n c r, it can also be written as in brackets n on r. So that is the choose notation here. I want you to rewrite it again. Oh, and either way you can write it. The thing is, yeah, people will write it the way they like, but if you see it written the other way, you just have to recognise it as the same thing. So n choose r is the same as this. This is also n choose r. This is actually called choose notation. I kept saying the other one was, but it's this one. It doesn't matter. I say n choose r. Okay? So, just some examples. And I'll do these from the textbook. So, just some examples based on exercise 10.1. Are we okay, everyone? Exercise 10.1 examples. That way you can actually go home and do some homework tonight. So let's go. This is an example from question 1. I'm going to do question 1. Actually, I'm going to do similar ones to question 1. I'm not going to do exactly the same. Question 1, type. I'll just go. Can you do 6 factorial over 3 factorial? Now, I don't want you doing it on your calculator. No calculators, we're just going to work it out. So what does 6 factorial mean? 6 times 5 times 4 times 3 times 2 times 1, but I'm not writing it all out, times 3 factorial over 3 factorial. Did you see why I stopped at the 3? Do you remember doing these last year? What happens? They cancel. And let's just do 4 5s are 20 times 6 is 120. So in question 1, where I get you to work something out, can you do it like that? That's a question 1 type. An example from question 2. Okay, let's look at something like, now that is not choose notation. If it was choose, it should be 6 factorial over 3 factorial, 3 factorial. That's not a choose type. That's a permutation there, not a combination. All right, let's look at this. I want you to evaluate. So it's all evaluate. So can we evaluate this one? 12 choose 12 on 5, which means 12 choose 5. How do you do that? What does it mean? 12 factorial over 5 factorial times 7 factorial. So if you were working it out, I know you can do this on your calculator, 12 choose 5. We're doing it by hand, but isn't that 12 times, where are you going to stop? 8 times 7 factorial over, now I'm going to write over 7 factorial, I'll put that one first, times, I'm going to write 5 factorial out, watch. 5 times 4 times 3 times 2 times 1. I'll tell you why I'm going to write it all out. So I did the 7 factorial first because I'm going to cancel it.
5 times 2 gives you 10.
That's right. So I did 12 factorial. I stopped at the 7 because I can cancel the 7 with the 7. I decided to write the 7 first here. But let's see what we can do some cancelling with. 5 times 2 is 10. What else can I cancel?
And the 12 is 3.
Yeah, 4 times 3 is 12. What does it equal?
11 times 9.
I did forget the 9. Thank you. There's a 9 in there, by the way, and I'm... So I've got 11 nines, and, well, 9 times 8 is 72 times 11, 792. Sorry, I forgot the 9. I thought it was ending a bit quickly, but that's what you can do. So you can go, the 5 factorial, write it out. The 7 factorial, I kept it because it would cancel, but 5 times 2 is 10 and 4 times 3 is 12. No, I'm just showing you. The reason I'm doing this is later you're not going to do this with numbers. You're going to be doing it with with n-1s and n-2s. And that's why you get used to it with numbers, and then you'll use it with symbols. Okay? Yes, it is a time waster. But question 3, I'll go over the page. Can I rub this? Can I go over? All right. I'm just doing examples from each. Question 3 is to show that, say, they've got that 9 on 5 equals 9 on 4. How would you show that without working them out? So you'd go 9 on 5 is the same as, what is it? By definition? 9 factorial over 5 factorial. I'm going to write times 9 minus 5 factorial. Do you know what I mean? Which is 9 factorial over 5 factorial times 4 factorial. You could, but I'm just showing every single step. Okay? No, if you're showing it, I'd probably put the intermediate step with showing it. And then you could say 9 on 4, isn't that 9 factorial over 4 factorial times 9 minus 4 factorial? Because isn't the formula NCR is n factorial over r factorial times n minus r factorial? So I'm trying to use that formula, this one, that NCR is n factorial over r factorial times n minus r factorial. That's what I'm using to show that. Reason I'm doing it, yeah, it's fine with numbers, but later you'll be doing it with other things, all right? So isn't that 9 factorial over 4 factorial times 5 factorial? So therefore, they're the same. I'll just go like that, equals 9 on 5. Got it? All right, I'm just trying to reinforce the formula here. I know you can do it on your calculator. Let's look at another one. So this was 3a, so you won't have to do 3a again. Let's look at 3i. You have to prove that 10 choose 6 is the same as 9 choose 5 plus 9 choose 6. Where does that rule come from? We did this at the... It's from who? From where? Pascal's triangle, that's right. That the number underneath is the sum of the two above it. See, 10 choose 6 will be sitting here, wait, here, and the other two are above it there. Remember those in Pascal's triangle, how one number is the sum of the two above it? Okay, so this is what that is. These are in the 9th row, the 5th and the 6th number in the 9th row, or actually no, but you go choose 0 first. So the 6th and the 7th term in the 9th row, and that's the 7th term in the 10 row, because it's always 10 choose 0 first. So how am I going to do that? This method. 10 on 6, which is what? 10 factorial. We can go straight to what it is. Over, let's use the rule, over, we'll just go what it is. 6 factorial, 4 factorial, yeah? All right, let's look at the right hands. Might have to play around with that. All right, we'll just leave it for now because we might have to do something else with it. Right hand side is this plus this, and you can't see what I'm doing. And what is it? 9 factorial over 5 factorial times 4 factorial plus 9 factorial over 6 factorial times 3 factorial. Geez. What are we going to do? One sec. Fractions here. To add them, I need a common denominator. I'd look at the highest one here, 6 factorial. I can easily make 5 factorial into 6 factorial by timesing it by 6. And I can easily make this 3 factorial into a 4 factorial by timesing it by 4. So I'm going to times the first fraction by 6 on 6, and I'm going to times the second fraction by 4 on 4. So I've got what I've got there times 4 on 4. Now, how can I rewrite this? This is 6 times 9 factorial over 6 factorial 4 factorial plus, this is good, 4 times 9 factorial Because it's 9 factorial times 4, which is 4 times 9 factorial over 6 factorial, 4 factorial. Now, girls, these are like terms. 6 lots of 9 factorial plus 4 lots of 9 factorial are 10 lots of 9 factorial. Does that make sense? Now we're talking algebra. 6 lots of 9 factorial plus 4 lots of 9 factorial is 10 lots of 9 factorial over 6 factorial, 4 factorial. Now what's 10 times 9 factorial? I know. It's 10 factorial over 6 factorial, 4 factorial, which happens to be 10 on 6, or 10 on 4, but they want 10 on 6. Oh, we did it. No, it's something else. It's 9. Do you remember? So look, let's look at what it means. 12 on 3 means what? 12 factorial over 3 factorial times 9 factorial, which could be 12 factorial over 9 factorial times 3 factorial. You know how, do you remember, if you do 12 choose 3 on your calculator and 12 choose 9 on your calculator, you get the same answer. Yeah.
But then in the exam, if we said y equals 3,
No,
isn't it still right?
it is, but it's not what they're looking for, is it?
That just equals itself.
It just equals itself. Girls, no, you'd probably get it wrong because that's just too... All right? 12 choose 3 is the same as... Do you remember we did this yesterday? Shh. For example, what's 5 choose 2 the same as? 5 choose? And what's 10 choose 8 the same as? 10 choose 2. It's that idea of the... Not complement, but... and it comes from the definition. 12 factorial... 12 choose 3 is 12 factorial over 3 factorial times 12 minus 3 factorial, which is 9 factorial. But if you swap them around, it now becomes 12 choose 9. Does it make sense? Because if I get rid of all that, that's really 12 factorial over 3 factorial times 12 minus 3 factorial. Or this one is 12 factorial over 9 factorial times 12 minus 9 factorial. Now, they give you the same thing by the definition. See, 12 factorial over 9 factorial, 3 factorial is really this. 12 factorial over 9 factorial, 12 minus 9 factorial according to the definition. NCR is n factorial over r factorial, n minus r factorial. And if you look at this, NC3, 12 n factorial over r factorial times n minus r factorial. So if you see that, of course the answer is 9. The answer is y equals 9. But that's what they're looking for, right? Now, let's look at some factorizing. Question 10 examples. Can I move on? You know all this. Factorize. Ooh. I'll do D. Factorize k minus 1 factorial plus k plus 1 factorial. Girls, please. How would I factorize that? You need to break one down until one becomes the other with extra bits. I'm going to keep the smaller one as is, because you can tear down the bigger number. You know how 10 factorial is 10 times 9 times 8 factorial? We're using this idea. So how can I make k plus 1 factorial look like k minus 1 factorial? K plus 1 times 1 less than k plus 1 is k. 1 less than k is k minus 1. Is that where I stop?
Yeah.
Factorial. Girls, k plus 1 it is like me doing this. I might say to you, factorize 9 factorial plus 11 factorial, or add them. You would say 9 factorial plus 11 times 10, just wait, times 9 factorial. Can you see I've got a common factor now? That is what I'm doing. Girls, I'm doing it with numbers first. If I say to you add 9 factorial and 11 factorial, you would go like this. 9 factorial plus 11 times 10 times 9 factorial. What's that? That's the same as 9 factorial plus 110 lots of 9 factorial. See, I've got a common factor now. I can factorize that if I want. Now, with this, k plus 1 factorial is k plus 1 times k minus 1 factorial, because you're supposed to go all the way down. So what's my common factor?
K minus 1.
Do you want me to keep going with the numbers? Do you get the idea? Can you see here now, if I was to do and continue there, what's my common factor if I was to factorize this? 9 factorial, what would I put? 1 plus 11 times 10, 9 factorial, 1 plus 110 is 111. So this is 111 times 9 factorial. That's doing it with numbers, factorizing that with numbers. Now we're doing it with pronumerals and k's. So this is the bigger one. It's only the bigger one that you can break down. That times the number below it. And you stop when you get to the same number and you put factorial. Because that's meant to go all the way down to 1. So now what's my common factor? K minus 1 factorial. What do I put here? 1 plus k plus 1 times k. Now I can, what does that equal? 1 plus k squared plus k. So I'm going to write k squared plus k plus 1 to get it in order. I know, it's 1 plus k squared plus k. Let's just write it in order. K squared plus k plus 1. I don't think you could factorize it unless you had the 2k in the middle. That's it. Are we okay? 1 plus k squared plus k. So that's an example of factorizing. I think I might just do F as well. Factorize this. Can you do it on your own? Factorize that. T factorial plus t plus 1 factorial minus t minus 1 factorial. How would you factorize this? Girls, I'll be looking for which one's the biggest one. The biggest ones. There's 2 that are bigger. Well, that's the biggest, but I want a factor for all 3 of them. You need to bring them all down to the smallest one.
Yeah, t minus 1.
That's right. So what do I start with?
T times minus 1.
Factorial, that one's done. Plus times t minus 1 factorial minus t minus 1 factorial. Do we have a common factor? Good. Factorial times t plus t bracket t plus 1. Yeah, can I just expand it now? T squared plus t. What else have I got? So are we okay with me doing that? I did t plus 1 times t is t squared plus t. So I've got, t squared, no you can't because it's minus 1. If it was a plus 1, you could factorize it. There's no 2 numbers that multiply to give negative 1 apart from I. Oh, good, I'm recording. C, just to simplify, n minus 1 factorial over n minus 2 factorial. N minus 1 factorial is bigger than n minus 2 factorial. You could check by substituting a value of n. For example, if n is 10, you'd get 9 factorial over 8 factorial. So we get n minus 1 times n minus 2 factorial over n minus 2 factorial. What cancels? And it's just the same as n minus 1. That's an example from question 11. Question simplify those. 12e, simplify, leaving your answer in factorial form. How do I do it? What is it? 10. Use the definition. How do I do this? 10 factorial over 7 factorial times 3 factorial divided by, so that's all of that divided by 8 factorial. So where is that 8 going to go? Down the bottom or up the top? I think it goes down the bottom. Because it's times 1 over 8 factorial, isn't it? So it's 10 factorial over 7 factorial, 3 factorial times 1 over 8 factorial, which is 10 factorial over 8 factorial, 7 factorial, 3 factorial. Now we need to simplify it as much as it will go. So what should we do? 10 times 9 times 8 factorial over 8 factorial. I think I'll just keep the 7 for now, but I wouldn't mind breaking down the 3 factorial into 3 times 2 times 1. We've got to go as simple as this will go. So what cancels? Yeah, the 8 factorials cancel. So it says simplify, leaving your answer in factorial form. So 8 factorials cancelled. What else can you do? We could, yeah, but what does 7 is going to go into? Why don't we put the 3 into the 3? The 2 into the 10 is 5. I don't know, you can't break the 7 factorial up because you can't keep the 7, break half the 6 up, break the 5 off. It's got to stay as 7. So girls, what's left on the top? 15 over 7 factorial. I would leave it like that. That can't be simplified. No, I wouldn't. I'd probably leave it like that. If someone wants, I'll check the answer. G, just writing each one according to the notation divided by the other one. Change the divide to a times and flip. And then you can cancel the 8 factorials. Then you can start winding some of them down. Which ones will you? So I'd keep the 5 factorial because the 5 and the 6 sort of go together and the 3 and the 2 will go together. So what would you do with the 3 factorial? 3 times 2. And what are you going to do with the 6? 6 times 5 factorial and keep the 2 factorial. And cancel the, good. Match them up first and then do your, what do we got? A half. Okay, all good. And this last one, you're going to try on your own, question 15. You need to show that n on k equals n minus 1 over k minus 1 plus n minus 1 on k. Now this is more the sort of stuff that you would be asked to do. Maybe. I'd have to look at. Go on. So guys, why don't you have a go at that one? I'll just, right hand side is, and I'd be writing it straight away as, oh, this can be messy. All right, let's go. What are you going to do? N minus 1 factorial over k minus 1 factorial times n minus 1 minus k plus 1 or minus 1? Number on top of another one. So that would be that number over this factorial times that minus that factorial. It's like 12 on 3, for example, is 12 factorial over 3 factorial, 12 minus 3 factorial. That's what I'm doing. This type of thing, but not with numbers, with letters or pronumerals. So, what do I do here? That minus that. Let's do it in one step. What is it? N minus 1 minus, I'm not going to put brackets, so minus k plus 1. Minus k plus 1, thank goodness for the plus 1, because it cancels with the other one. plus, what's this one?
N minus
N minus 1 factorial over k factorial times n minus 1 minus k factorial. Now, before we go common denominators, we better simplify the first one. N minus 1 factorial over k minus 1 factorial times n minus k factorial plus n minus 1 factorial over k factorial. Can we write this as n minus k minus 1 factorial? It's much better because, do you see it now? So which one's one bigger? This k is one bigger than that, and this is one bigger than that. To make common denominator, you've got to go common denominator. What are you going to multiply by what? What's this one missing that one's got? See, to make this into a k factorial, you times it by k on k. N minus k is one bigger than n minus k minus 1. So let's look at the groups. You're going to group, see the k is associated with the k minus 1, they're partners. And the n minus k is almost the same as the n minus k minus 1. Looking at the underlines, the straight underlines, what's bigger? K or k minus 1? K. So therefore this is just missing a times k. So I start with my first fraction and I go n minus 1 factorial times k, so I'll put the k on the front. And doesn't this become k times k minus 1 factorial times n minus k factorial plus, let's look at what this one's missing. N minus 1 factorial, what am I multiplying this one by? Yeah? N minus k, just a normal n minus k, not an n minus k factorial. So it's being multiplied by n minus k. So I've got k factorial times n minus k.
Why isn't it factorial?
Oh, it will be. No. Wait. The bottom will end up being n minus k factorial, but you're just timesing the top and the bottom by n minus k. Because when you times this by n minus k, you'll have, it's one bigger than that. N minus k is, so now you don't have to write this like this, you'll write this as n minus k factorial. I need paper, one piece. Because I need to make this into an n minus k factorial. Well, I need to times it by n minus k to do that. So whatever you times the bottom by, you have to times the top by. Whatever you times the denominator by, you times the numerator by.
He's like 8.
Just one.
On top of him.
I just need one. And that's my banana from yesterday. Jeez. So, I've got rotting produce. I don't want to know. So, equals. Oh, yeah. Equals. Now, this is more like what we want to be doing. So, see, you've got to decide what your lowest common denominator is going to be. And I've underlined the two types of pairs. With the k and the k factorial, k minus 1 factorial, this one just needs an extra k, k over k. With these two, the squiggles, n minus k is bigger, one bigger than that. So you times this by n minus k on n minus k. And that will now become n minus k factorial. So what we're left with is k times n minus 1 factorial over, what's this? K factorial times n minus k factorial. Girls, this other denominator is identical. K factorial times n minus k factorial. So I'm going to just put the one denominator plus n minus 1 factorial times n minus k. So they're both the same denominator. Or if you want, I'll break them up. One denominator equals. What can I do on the numerator? It's one denominator. What can I do on that numerator?
N minus 1
n minus 1 factorial is a common factor. N minus 1 factorial, what's left over? K plus
minus k.
n minus k. N minus k doesn't have a power, so I can just write it as n minus k. Now what do I do? What does k plus n minus k equal? What's n times n minus 1 factorial? All right, I'll just leave it as n times n minus 1 factorial for a sec. Now, n times n minus 1 factorial is n factorial. Now, what's this in the form of? Isn't that a rule? Isn't that NCK? That equals n on k. That's the rule for NCK, isn't it? N factorial over k factorial times n minus is the rule for NCK equals n on k equals left-hand side.
Can we test it on these?
Yes, I'll be throwing one of those in. Maybe. I love them. So, that your homework is exercise 10I. I'll be doing a video over the weekend for 10.1. Girls, I've gone through a lot of the theory for 10.2, so some of it. I need to iron it out a bit more. So I'll be doing a video on 10.2 for, to make up. I'd rather us have time at the end. I'd rather us get this done. Let's have time at the end to do some revision. All right. 10 question. Just do it like, I reckon just question 1, 1E, H, can't remember what I did. I, that's easy. Question 2, can't remember what I did. Yeah, I did. Question 2, I only did 1. Can you just do 2? They're easy. D and J. Question 3, I did A and I. You can do question 3, A and I. I'll just do one of each. Why don't you do, and you're showing, which means you're proving, do D and J. Can you do question 4? And 7 takes about 2 seconds. 4, 7, 8, and 9. They don't take long. I'll give you 1 from 10. Question 10, let's just do a factorize. We've done D and F. I'll just give you E. 11, we've done C. 11C, you can just do E, 11E. Question 12, we did E, so why don't you just do 12D. 13, we did G, you can do F. 4 and do 14. There. I'm just getting you to practice one more from each. They're very... All right? Got it?